Okay, so what we do tonight is talk about troubleshooting, and again, this is for the recording. They have a lecture which has a few slides, and I'm going to use them. I'm going to use the step by step. And what I'm going to try to do, is simulate what he's done in the chapter, and go through step by step what the troubleshooting is in the packet tracer simulator here, so that we can hopefully do these things. The objectives, always objectives, are identify and correct common network problems. What I'm probably going to do is, I'm going to go through his, and sometimes I think that there are things that are a little bit quicker than maybe what he does, because he'll go through and start pinging the 127, and this is the proper way to do it, the 127.0.0, and see if everything's working. Then he'll ping the local address to see if the TCP/IP stack's working. Then he'll ping the default gateway. Then he'll ping someplace else. I always like to ping the other side of the router. But if everything else is working to the gateway, you can shortcut that by pinging the default gateway. If the default gateway works, then the 127.0.0 works, the ping your own local host works, so the IP stack's working, and you're getting to the default gateway. Generally, what we're going to find is it's going to be someplace in the routing, and it's easy to make little typos, as you've seen, I think, when you're doing configuration. So I really think that the routers are generally the most likely one, because hosts we're probably going to use DHCP, and if we use DHCP, not a whole lot of mistakes there. If the NIC fails, then you're going to have an issue, but those failures today are fairly common. 15 years ago, not so uncommon. Today, pretty much uncommon for a NIC to fail. Although they do, hardware always does fail. So identify and correct common network problems, resolve routing issues, and I think that's honestly where most of everything will be. Be sure routing is enabled, the route table is correct, correct path selection, default gateway, and the correct path selection goes back with routing issues and route tables, the route table correct. Troubleshoot and resolve VLAN routing problems, and VLAN, we'll look at a couple of things there that it can be. Connectivity, encapsulation. The switches that I picked in the simulator, you can't configure. You remember when we talked about VLANs earlier, there were two protocols that might be available: ISL, inter switch link protocol, which is Cisco, and the .1Q, right, 802.1Q. Most of the new switches, I think, and anybody can probably prove me wrong, but .1Q is going to be the most popular one. If it is the only protocol that's there, you don't have an encapsulation option. And native VLAN is something that, yep, it's there. He has you change it and says, oh golly, it's not there. If you change the native VLAN, it doesn't match, you'll get error messages up that just drive you batty. You can change it. They recommend that you change it someplace out to where somebody gets on your network, that way they can't do any damage. The default native VLAN is VLAN 1, which is everything is. And then port trunk status, actually that we have port trunks to do these things. So the Cisco objectives are clear on the troubleshooting steps you need to take when a problem has been reported, and this is straight out of the book. Check the cables, and in a lot of instances, particularly the place where I work, cables were probably 90% of our problem. Most of them have been made because you have a switch and then you run the cables to each of the workstations, however many long. Well, if you tried to buy prefabricated cables, and you guys make fiber, so you kind of know where I'm coming from, but what we'd have is students sometimes make these cables, and sometimes they're not so good. They're not nearly as proficient as you all are. Maybe proficient like you were the day before you started making them here, something like that. But check that. They also, if we have RJ45s, copper, if you're in a humid environment, you can get corrosion. Sometimes just unplugging it and plugging it back in. In the old days, we used to have what we call thermal creep, and you may get a little bit of that. But generally what happens is people tripping over these cables and pulling them off, breaking the tabs off, and they back out. So check the cables to be sure. And on the back of the NIC, bad drawings, I know, there's going to be a light there, a little light there. Is it green or not? That's the link light. Link light's green. You're probably pretty good at layer 1. And this is going back. We're going back to some of our OSI model stuff. So we're looking at, in the cabling, we're looking at layer 1. So whatever that is. Faulty cable or interface in the mix to verify the statistics. And we can look at other things and remember that our duplex and speed have to match. And if they don't match, zombie, we're done. Mostly we're going to use auto. Auto is great when it works. But if it doesn't work, you've got to know how to go back and set the duplex and the speed. That's really tough. The commands are duplex and speed. A duplex full, speed 100 meg or whatever it is. And don't be afraid to use the old question mark when you're doing configurations in routers, because CCNA question mark works. And as far as I can tell, there's no penalty, because I've used it on CCNA test, CCNP test. I passed them all, so I guess it doesn't really, if it does count against you, it doesn't count against you very much. Make sure that the devices are terminating the correct path from the source to the destination. One of the things that I can't do in the simulator that I can do, and I'll try it here, is use the command route print, which works on a workstation. It'll show you the route table on the computer. And the computer has a route table too, because it's got to know if it's a local or a remote. Just like everything else, if it's local, it's going to ARP4, except IPv6 uses the network discovery. It's going to ARP4 the MAC address and send it directly there. Otherwise, it's going to send it to the default gateway. Maybe a member of a multicast domain, those sorts of things. Manipulate the routing information. That the default gateway is correct. That can be a big problem. The default gateway, where is it sending it to? Is it sending the information to the right place? Verify the name resolution settings are correct, DNS. One of the ways to check that, if I can ping the IP, that wasn't a very good ping, was it? Ping the IP, but not the name, the FQDN, fully qualified domain name, then I have a DNS problem. That's a quick way to prove that. Or, but that also means that you need to know what the IP address is to get there. So maybe you want to at some point get your troubleshooting IP that I can ping this IP address, get a Yahoo, for instance. Yahoo enters ping. Some places don't. Microsoft doesn't enter pings. So if I can ping the IP address but I can't ping the name, then I have a DNS issue. So is that set correctly? Verify the name resolutions are correct. Do we have a DNS server? There are some public ones out there that I think he uses was 2.2.2.2. It is a legitimate DNS server. I think that's the one. It's either that or 4.4.4.4. They belong to Google, but they're publicly usable. Verify that no access control lists are there. And access control lists, remember, if we have one, we're going to have one, and it's really a dumb one, but we're going to have one on this one. That if we do something, we need a permit, otherwise permit, because at the end of it is a deny, and we'll just say all, deny any for an extended list, and just a deny for the simple ones. But this is the infrastructure that he uses, and the issue is he cannot log on to server 1 from the PC. Actually, it's worse than that. You can't contact server 1 from the PC, I believe. This is the infrastructure, and these are the devices. So let me keep those, and let me see if I can get my packet tracer going here. This is the same that we had here. So what we have, let's see, 172. You're gonna have to help me. You're gonna have to help me with these IP addresses. Let me move this over so I can see it. Let's see if we can go to command prompt, ping 172.16.20.254. And I should not get it because this is the one, hopefully, with the errors in it. So we're not getting anything. So based on the troubleshooting, troubleshooting steps that we're supposed to use, messed that up, didn't I? We're going to go in here, and I think I can still do this. And we're going to, what I wanted to do. Get rid of that. Try to get rid of that. We're going to test the local IP stack, the 127.0.0.0 when we do this. There's my pin. I knew I had a pin in here somewhere. So we're going to test the local IP stack. That's 127.0.0.1 or : 1 in IPv6. Then we're going to test the local IP stack, which is it's going to be it's 192.168. whatever number. Then we're going to test that the LAN is pinging the gateway. Then we're going to test that the host can get to the remote networks by pinging remote server 1. Well, we already know we can't get to server 1, so we're going to figure out how far we can get with this thing. Okay, so back to this. So we're going to ping eping, right? Ping 127.0.0.1, right? Cool. We got that. And we can check all this 10.1.1.1. So can we ping ourselves 10.1.1.10? Yep. Can we ping the default gateway? And that is the ping 10.1.1.1. And yep, we can ping it. What I like to do the next is, can I ping the other side of the router? This is me. So can we ping 192.168.10.1? Ping 192.168.10.1. And we can ping it. What else we can do is we can do a trace route. And I think we've talked about trace route before. When trace route fails, that's the router that's got the problem. So trace route 172.16.20.254. Let's see if we get here. So we get to 10.1.1.1, and that's as far as we're going to get, I think. Of course, I cheat. I know what the answer is here. But we can ping the other side. I wonder if we could ping the next one to .254 on this one. And then we'll get back to this is the way we're supposed to do it, okay? Well, I did something interesting there, didn't I? How did I do that? I've lost my network. Anyhow. Back to, so yes.
So we
ping. Let's see how far we know that we can ping to this one right here, to the .1, right? So let's see if we can ping 192.168.10.254. I think this is where we're going to have a problem. Okay? So I'm going to flip back and forth between what he says is next, and we'll just go here. So this is his scenario, ping, and I think we did all this. We haven't done the router yet. We can show the IP routes, and then he says on the router use these different scenarios here. So we can go to this guy and show IP route. We have the connected, the 190, the 10.1.1.0, the one that we're on that works because we can ping ourselves. The 192.168.10, the one that we're attached to. And then we have a default route which says go to 10.254 next. So we're probably okay at this end. And I'm going to cheat, go through and look and see. If you look at the book, that's what he's done. His first one, he did a route print. Let me see if I can show you that here on this, because it doesn't work in Packet Tracer. So if we go in here and type route print, we get the routing table of this thing. So it says that the default route, golly, goes to 172 here locally, 24.0.1, which is the default gateway. And this is my IP address, 174.24.2. You can look at this. It may make a little bit more sense to you at home, but 127.0.0 network, the loopback network, uses the .1 address, the 255. It's there. 127.255. We're on this laptop on the 127 network. So the 255, 255, 255, 255 is going to be. Excuse me, that's the 127. That's the link. We're on the 172. Too many 2s and 7s. I get my dyslexia kicks in. 127.24, 255, 255, 224. So they're using a 224 subnet mask. 192.192.224, which leaves us a whole bunch of hosts on this network. I mean, that's a lot of hosts in that position, right? 224 is 3 bits. That leaves us 5 in the third octet plus 8. So that's 13 bits. You can do the math on that one if you want to figure out what's there. And then we have the 172.24.2.135, and I honestly don't know where that one came from. And we have the 31 here. We have its. They just subnetted it differently. So not knowing what they've done, we could probably sit down and figure it out. But this is the route table that's on the computer. So we can look at that with the route print. And we also have an IPv6 route table. Those are there. You can look at them at home. Again, probably make a little bit more sense than because you kind of know how your network's set up there when we do those things. But this one has got the addresses that we need so that it can go to the default gateway. The default gateway, and you notice the gateway of last resort is, and that says that we have a default route. Default routes, again, are used when there's no specific route or connected a route to tell it where to go. That's why it's the last resort. I don't know what else to do. Okay, I'll go do what the default says. Okay? So we have that thing. So it's sending us probably to right here. And I think, and that's what he did, and then he pinged it to 10.1, just what we did in the 10.1.1.1. Pinged the 172.16, and he got the timeout just like we did when we got to the 254. Right? Mm-hmm. So he says now it looks like we confirmed that the local connectivity is good, and I think then what he does is he does the trace, and he gets the same result that we did 10.1.1.1 we got to, right? We can do that. We can do the trace route again. Trace or 172. No, it's not where we want to go, is it? Yeah, we can do 172. That's that. Okay, 172.16.20.254. That goes to the server one. So we get to the 10.1.1.1, and that's where it fails. Request timed out when it gets to the other routers. So it's probably getting to this guy here. And the next thing that he wants to do is go to R2 here, and what we're going to do is check the other end here. So can we ping 172.16.20.254? We're in business there. We got absolute success when we ping from here to here. That's not a big deal, is it? We could go back down here, actually go to this desktop and do the what I like to do, 172.16.20.1, is that what we're supposed to be at? So can we ping it? Ping 172.16.20.1. And it works. So what we've shown, and to me, cheating based on the number of steps, because we should have done the 127.0.0.1, then we should have done its own local address. But what this says is that the stack's working and the local IP is working. Otherwise, the ping won't work. Okay? The IP config, we looked at that, and we don't have, in the book he's got IPv6 addresses. So what we're going to do is go to router 1 or router 2, and what we show, interface, I guess if I clicked into this it would work better. Show interface 0/0. Simulator is not going to be exactly the same as his, but what it is telling us here, and that's why I had that note up here, it's up, the line protocol is up. Up is what we want to see. The first one that says that the fast Ethernet is up, this is layer 1. The line protocol is up is layer 2, which is Ethernet, which means that we've matched. Physically, we've connected it in, and they're both using Ethernet. Okay. When you go on down here, hardware is Lance MTU 1500. We got the bandwidth 100,000 K, and you notice this is in K bits. 1, 2, 3. It's going to be 100 meg. So this is a 100 meg connection. It should tell us the duplex, and I think on the real ones it will. It doesn't show you that on the simulator here. But I guarantee you that if the duplex were set wrong, and we can prove that here because we know how to do the duplex, we're in that interface, right? If the duplex were set wrong, I don't think it's going to work. So let's try. We're interface, let's go to interface fast, 0/0. Got to go into config first, don't you? And then we can do duplex and the question mark. If you spell duplex right, it probably works better. Tab works great for me. So let's see if I lied. Duplex, he does full, let's do half. Just for the heck of it. Okay? And now then, now we got to wait for spanning tree again, wait for our minute. I should have done these as port fast, right? So that they come up instantaneously. And I did port fast on switch 1, but I didn't do port fast on switch 2. So we will wait and stall. Oh, there we go. So let's see if I can make myself a liar. Still working, but that may be a simulator issue. I have done this on real devices, and if you have a duplex mismatch, it won't work. So let's go back to this guy. He brought it back up. Let's go back to duplex full. Actually, it probably still work. It will work. I lied. What it does is then puts the other NIC into half duplex. Let's see if it did that. Config. Yeah, it still says it's full at 100. And I think that some of that is for the with the duplex full. So that puts it into manual full duplex. If you do this, and again based on the actual equipment, and change the speed, we got duplex full and we got speed. Now let's try speed. Let's do speed 10, just to heck with it, just to force it into a 10 megabit per second. So based on that, it won't work now until we come back up, right? So we're going to stall again and wait for it to come up. 50 seconds. Checking for And again, what we're checking for here, and we could use port fast here because we're not going to plug a switch into here. It's looking for duplicate paths, looking for loops. Takes the 50 seconds about to do that. Orange or red, and you say red, and I agree with you, red. What's that? What does red tell us?
It's nothing connected.
Nothing connected. That interface is down, and if we go into the switch here, it says the line protocol on fast Ethernet 0 changed state to down. The line, and so let's go in here. Let's actually go back to the router because it's easy to see. There's not as many interfaces. Do show IP interface brief, and we get an up down. Up says that it's physically connected, again, physical connection. Down says that the protocol, Ethernet, because we configured one of them for 100 and the other one for 10. If we'd have had auto in those, which we don't because the switch is 100 meg, auto would have changed the 100 megabit port to a 10 megabit port. Okay, so let's go back to this guy and make the speed 100 and see if it helps us out any. May not. I may have to. Let's do a shut. This is called bouncing the interface, and sometimes you have to do that. You do a shutdown and a no shutdown. Now it says it changed state to up. So we're still up down because it hasn't come back up yet. But anyhow, we have. I still got a half dupe. No, we changed the duplex back to full, right? And speed back to 100. Change state to down. It's still unhappy. We'll pause it while we wait for this. Okay, so we got these things back to where they were. And let's see if we're still working over here locally. We are. And let's try something here just for the heck of it. Trace route. Let's see if we can get to 10.1.1. 10.1.1.1, right? Goes to 20.1 and it quits. Still look like it's not going, right? Request timed out. Which means it's not getting there. Timed out means that took too long to try. So let's go up to this guy. So we've done a whole bunch of stuff, right, on it. So I think the next is show IP route. And on the IP route, the static for 10.1.1.0 network goes out interfaced fast Ethernet 00. If we go back and look at this thing, and I can turn these on, options, preferences, and let's show the port labels. This is fast Ethernet 0.0. So it's sending it to the wrong place. It needs to go out fast Ethernet 0.1, or honestly, to me, the safe thing is to say what the IP address is. You don't get the interfaces confused that way. So on this thing, let's go in here and config T and do no IP route 10.1.1.0. And this was fast. I think that's what's supposed to go next. Destination, yeah, 255.255.255.0. And then ABCD, the address, the Ethernet, fast Ethernet 0/0. Right? Isn't that it? Let's see if we got rid of it. Do show IP route. And sure enough, we got rid of it, so we can now do an IP route. Did I do that right? Except it's 2 words. And we're going to go to 10.1.1.0, and it's 255.255.255.0. We could either tell it to go out fast Ethernet 0.1, or we could tell it to go to the next hop. And again, the next hop may be safer, and I think that's what he does there. 192.168.10.1. Okay, so now let's try the ping from here again. I don't know what terminal do I want to run. Or a trace route. Let's see. Bingo! We're there. Next step is, and he uses Telnet. These things don't have Telnet. So I have, and I'll show you in the services, I've turned on HTTP. I've turned on the web server on this thing. Okay, so that gives us an application layer to try to get through. So we can go to my little PC1 here and go to my little web browser and go to, what is it, 172.16.20.254. And I'm not getting there. Golly, I can ping. So ping takes us up through layer 3. And part of this is to show you, yep, that OSI stuff really is kind of important, because just because you can ping it doesn't mean it's going to work, because we can't get to the application layer. So the next step, and I think one of the next things he said was check for access list, wasn't it? So let's show access list. And golly, looky here. There's an access list and it says permit ICMP, any. So it let us ping. But what's the problem with this access list? There ain't no permit after the permit ICMP any. What's the next statement going to be? That's the implicit or implied, or that's there that you don't see it, deny any. So the only thing that this access control list is allowing on this system is ping, because the deny any that's always there is there, and it's stopped everything else. And we have the 29 matches here. It's working, it's letting the ping through, but it's not letting anything else through. So that's access list 110. So let's do config t no. Let's just see if we can make it go away. 110. Do show. And we don't have any. Now let's see if our little guy here, and hopefully we're going to be able to get there. So it's 172.16.20.254, is that right? Now we're there. So we went through that whole process. Yeah, that's the way that you should do it. Most people are going to take some shortcuts. Trace route. Trace route gives you an idea of how many of the routers are working. And it kind of gives, as you saw, kind of gives you an idea of which one's not working, because you got this far. Okay, I'm working this far, and then that's as far as it's getting.
I would never think that. I guess I would think if my ping is working,
that everything else is.
Yeah.
That's why the last one is check for access control list. I may have told you this, the last place I worked, the network administrator had a problem with one user that they wanted to keep off of the internet. Wrote access control list, deny this user's IP address, put it on. Network went down, internet went down, network didn't go down, internet went down. Because he didn't put it down like everybody else. There's that implicit deny any after all of those. That had a permit statement. but it only permitted one protocol. Then you could permit any afterward. That's been kind of a silly access control list. It's like not having it. Usually, what you're going to, I was going to say what you're usually going to start out with is deny, but that's not necessarily true. You may want to permit an individual IP address access any protocol to a particular destination and then deny everybody else. For instance, if you were the network administrator and you wanted to do remote access to a server and you're the only one that could do it, you could put an access control list on that. The first statement, the most specific statement, would allow your IP address to get there. And then the next one would deny everybody else. Of course, it's already going to be there, so all you would have to have is that one permit. But you have to have, and it would work very similar to this one, it would only allow that one address to get there. Make any sense? Troubleshooting? Get rid of this. Let's go back and see what else he's got on this thing. He's got an IPv6. It's a similar process. We're going to do that. One of the things about IPv6 is it does use the link local address for some things. So we have the IPv6, both the link local and the global addresses. You can use both of these. You can use the link local for routing. Oh, that was really nice of me to do that one. You can use the link local here for routing. I turn my pen off, didn't I? You can use this. I will get there. You can use the link local for routing. If you do, you have to specify the interface that it goes out and the address. So in the route table for IPv6, we could use the next hop, we could use the interface that goes out, or we can use the link local address. What they do say is that when you have these computers down here, the default gateway is the link local address. So you do use those in IPv6. I wonder why it kept those there for me where I didn't want them. It does lots of things for me that I don't want. So this was our IPv6, and so you start it back and those lines aren't there anymore. Or are they? Yeah. So ICMP, IPv4, the one that we're all using and trying to get rid of, I guess the pen's still on, uses ICMP to do things. Uses IPv4 uses, it's not going to show me where my pen is it? Let's try. It's really mad at me now. Okay, so we're going to use ICMP for the test error messages and those things. Is not an integral part. It says this should say IPv6. Is an integral. ICMP v6 is there. v6 is used for router and neighbor solicitation, and that's what this thing is going to use. It's going to use neighbor discovery and neighbor. And we talked about those. Hey, tell me about yourself. And you can list, and it's a netstat command. I think it's a netstat command in Windows, and you can look it up on the internet. But you can go in, and it'll tell you who your local neighbors are. So you get a list of those, and then it's done by ARP and IPv4. And we said the other night that neighbor discovery replaces ARP. It is the IPv6 ARP. So we're not using ARP in it. And the network discovery determines the MAC addresses, the router solicitations, and sometimes Cisco does like to ask you these multicast addresses. So some of them are maybe handy to kind of have tucked away. And there are a few, but there aren't that many. But the router solicitation and the router advertisement, FF02, and FF02 meant that it was going to be multicast, I believe. Is that right? So : 1 and : 2 are going to be the solicitation and the announcement, the router solicitations and the router announcements for these things. And this is the same picture that's in the book. The router solicitation basically says, hey, all you guys answer me, use me. When it does the router solicitation, they send back the traffic. I enabled IPv6 on my router at home, and you know what? All that stuff works. It actually creates the AUI 64 address with the FFFE in it. I get those. It gets a network address, an IPv6 network address. It gives my workstations an IPv6 number. So all of this stuff does work. The advantage, and we talked about those HSRP, the multi-routers so that we have redundancy. You can actually have 2 gateways in IPv6. So it does improve things quite a bit. So we have those. And the neighbor solicitation, the neighbor advertisement, same thing, but what they're talking to, these are computers that are talking to each other. Tell me your MAC address. And this in IPv4 would have been our ARP protocol. So we replaced ARP with this thing. Troubleshooting, check cables, same thing. Make sure the devices are the correct path. Same thing. Are the route tables correct? Is the gateway correct? And remember, the gateway here may be the link local address from the system. Verify name resolution, which we didn't do in our example. But again, if you can ping the IP and you can't ping the FQDN, then it's going to be a DNS issue. Verify that there are no access control lists, and again, we saw that one. That if we can still ping, we can ping it. Then ping only takes you to layer 3. You may need to go to the application layer, and that's where the access control list. The access control list actually limit which application layer services that you can get to with these things. So the troubleshooting commands, let's see, I've got this one simulated too. Okay, so this is the same infrastructure. I think it's in the book. Is that a true statement? I believe.
Yes.
So what we're going to do is basically start the same way that we did before. The same process, except we're going to use IPv6. We're going to ping the loopback address. Ping, what is it, : 1, and that's the only thing to me that's really easy in IPv6 because remember, you don't have to have the leading 0. So that one works. And the next thing we're going to do is ping our local address. And what I have kind of learned to do, particularly with IPv6, is copy them and paste them because they are so long. So let's see if we can ping our, it says that we can't, huh? Did I not get it all? Quest time down.
So you ping the : 1?
I ping : 1.
Okay.
You know what? I pinged the wrong address. Let's see if we can ping his real address. And again, I'm still trying to do copy and paste because I make so many typos, and I'm obviously making copy and paste typos, which is tough to do. Let's see if this one works. Okay, so the real address works. And if you look in the book, I think he used the address. Yeah, he uses it, and the addresses that are in the book and the addresses that are here aren't going to necessarily match up because of the MAC addresses. The link local addresses, the FE80 addresses, FFFE addresses aren't going to match up because they use the MAC address. So we did those, and then what does he do? Ping the 9B2, and his 9B2 is which one? Okay, so well, we ping the local one. Our next thing that we actually would ping would be the default gateway. I think, is that not true? Based on the process that you've used before, and to the router. So we're going to ping the router. Let's see if we can ping its link local address just for the heck of it. Control C, because the default gateway is probably going to be the link local address, not the public address. And let's see if it doesn't show me the the link local IPv6. Yeah, it doesn't show me the IPv6 gateway. So limitation of the there are some limitations of this thing, and we can do the same thing, and then we're going to try to ping. What's the next thing that he needs to do? 2001. The global address on R2, the FA00. So we can. This is the one he wants to go to, FA00, right? Wants to go next. Probably do this one. Let's see if we can ping this one. Just for the heck of it. I'm doing Control C's and Control V's just again because I can, but so we can ping as far as this interface. Can we ping the next interface? And this one I don't think has the all of the routing table errors that the first one did. Ping. So we can ping there. Now we want to ping to the other side of the FA00, all right? We've done good so far, right? But are we supposed to have the problem here? Destination host unreachable. So now we can't get to that one. So what does he want us to do? Trace route? We can do that. We already know that it's unreachable. So let's think what we're going to do is look at the route table maybe. So show IPv6 route, right? Our interface. Show IPv6 interface. Brief. So we have these things up, administratively down VLAN 1, but everything is up. A443, I think we're the same as we're going here, right? And we're going to ping the next one instead of trying to write all these things in. Let me ask you something.
So one says fast Ethernet is up, but administratively down.
That's VLAN 0 down here. That's kind of a tricky one. Yeah, I looked at that first and said, wait a minute, what do you mean down? That's VLAN 1.
Yeah.
It is down on that thing. Now we could do the show IPv6 neighbors, and we'll do that on R1. Let's just do that here. Show IPv6 neighbors, and we have the 2001. And these things show reach, and some of his are wrong here, but 2001, the A44F, and if we go look at these things, the A44F is this router over here, which tells me that We ain't talking to the, we're not getting the neighbor back from this device down here. Because he shows the R1. I'm kind of jumping some of them. And I actually have forgotten what's wrong with this one. So we'll go to the desktop, and he wants us to do an IP config, right? V80, we have the temporary address, and there it is, the net shell net sh interface IPv6 show neighbor. You can do that on a computer, and it will show you the neighbors. Actually, I guess we can maybe do it here if it will. Net shell IPv6 show net shell interface. And don't make me a liar, but okay, so Ethernet address gives you a whole list of what's going on here, a whole list of addresses, and it gives you the route tables, and IPv6 is going to have unreachable. See, we have some addresses here that are just like he says, unreachable permanent. Whole bunches of addresses in here that you can see. So we're going to go through this thing, and we're going to show what we're going to do on R1. I don't think R1's the problem, is it? Checked all of these things. Okay, R1 tells you that a lot more than, okay. Oh, that is, R1 is the problem. It is the problem. Show IPv6 route. This one doesn't have a route out. You notice that they're all C connected and L local, the local routes, and the local routes don't really take us anywhere. Fast Ethernet 0. So what we need to do here is to put in a route, and let me go over here and we'll look at the IPv6 route here. Here we have a static route that says that we're going to go back to the other address. So on it, IPv6, and you notice that it's : 1. So let's go and see if I can actually get this thing in here. So config T, and it's IPv6 route : :/0. That's going to be the equivalent of the 0.0.0 with the 0.0.0 subnet mask. The default here. We're going to go out fast Ethernet 0/1, and then if you'll notice in the book, it's the FE80. I'm going to go up here and copy. Yeah, but it's going to be different. The FE80 that's actually on my routers is different from his, I think, because the MAC addresses are different. I would have to have his equipment here to do that, which we don't, obviously. And then we'll do a paste in here. And now, with any luck, what was the last one that fails? That one, right? So we're going there. We could go through the whole trace route thing that he does, and again, you can get these. You can download them from the share if you want to play with them. We could go through that whole thing that he did, and we still come back to this.